Hey, welcome back to the stream, folks. Got a little streak of streaming every day here. Normally there isn't really a schedule. We just stream things when there's something interesting to do, but yeah, managed to actually get stuff together today, just a little bit. Just continuing the Winch assembly some more, but thought we could share that. We'll have a variety of cats available on today's stream. So, for anyone who's new here, I've been kind of semi-willingly been more of a crazy cat lady than usual lately. I've got one cat of my own. He's the little guy who's on the carpet just there, Tuco. He was the inspiration for this flying project thing. And, oh, Tuco's destroying things. Oh, yeah, I'm sorry I killed the wasp. Maybe I should have just taken it outside. I just didn't want a wasp in the vicinity. Yeah, it was probably a pretty mean thing to do. This is Luna. She's one of two cats that I've been kind of long-term cat sitting lately. The other one is actually in a cage behind me. He's been recovering from leg surgery, and so he needs to be in kind of restricted activity for a little while, like a couple more weeks. So yeah, the cat situation has been a little bit weird. Oh, it looks like we've got some comments in the YouTube chat. Oh yeah, it looks like Brian Rosales says, or asks, has the post on Reddit improved the following? Yeah, it looks like it maybe doubled the YouTube subscribers, so that was pretty awesome. It looks like there might be a lot more people who know about the channel now, so been grateful for the extra traffic there. Oh, and yeah, Mike's Radio Repair asks how the kitty's leg's doing. As far as I can tell, his leg is doing great. It's just that he's now just like very eager to run and play on it, whereas doctor's orders are that he needs to be very careful with that and no running and jumping and stuff. So I've been just like, anytime I have the time to pay attention to him, so usually a couple times a day, I've been letting him out for like an hour or two. And then just like paying attention to him and trying to stop him from doing anything terrible. But let's keep an eye on him, since that's him yelping behind us, wanting attention. Well, maybe we can start with some cloud fuzzing. Yeah, there's the poor little guy. Get a close-up on his leg. I don't know how much you can see the leg right there, but his front left leg is the one that he broke. And so it's like the hair is growing back. There's a slightly wider area where it's got some kind of like, there's like the scar from his surgery, but he's been recovering super well. And so actually maybe, yeah, I'm sure a lot of folks are worried about Cloud, and he's been jonesing for some more time outside the box, so maybe we can do that a little bit on stream, and I'll put on the headset mic so that I don't have to yell at the shop microphone. Yeah, that little guy has been so good. He's only like a year old, and he's also really big. I weighed him the other day. He's like 13 pounds. I think Tuco is 12 pounds, but he's just like a big muscly like house leopard, whereas Cloud's a bit more of just like a big old marshmallow. Like he's just like a really adorable fluff ball, but like he's maybe less well built for the jumping off of things. Oh yeah, we're gonna do it live. Yeah, I think all I have to do now is unmute this channel, and maybe you can actually hear me on the wireless. I should actually check that on the headphones. Does that sound like anything? I think we're good. Let's bring the beer and the camera over here. One danger is that the other two cats have been fairly active around this area lately. I was more worried about them all getting into a fight when they hadn't eaten dinner, so they've all eaten. I don't think I have to worry about him stealing the other cat's food because, oh, this is so hard to focus from across the room. I don't think I have to worry about him stealing the other cat's food since I think I put all that away, so I think we just have to worry about them just like starting good old-fashioned cat violence. Because like you can see, the other cats are just right over there. There's Tuco on the left, and the Luna is sitting on that red chair. The intention was this channel to be more of like forward and reverse engineering, but let me know what you think about the crazy cat lady content, because like that's certainly easy for me to produce at the time. I'm looking forward to being back to a one-cat household, and I'm sure these folks are looking forward to being back with their mom, and vice versa. Alright, boy. Hey, let's leave calmly. Don't just, like, run out of here. Hey, oh, you're so eager to get out. Oh, my gosh. Oh, yeah, can I just... Oh, yeah, you just want to run, don't you? Okay. You doing okay? You seem great. He just wanted to be out of the box. Oh, wow. Whisperfist has been moving a bunch of wasps. Oh, that sounds really, really difficult. Well, more power to you. I'm really glad if you can deal with that. Yeah, I probably should have transported the wasp instead of killing it. Are you inspecting the quality of those jumper wires, Cloud? You don't like them either, right? They're mostly garbage. I threw away the worst ones. The ones that I have, I think, are mostly better. But I'm gonna have to be skeptical of them until I can reorder them from a quality source. There was a little bit of hissing there. Oh, that is Luna growling. Luna is very protective of her personal space. Cloud, you should know that. You've lived with her for a while. See, he doesn't seem to be limping on it at all. He seems to be just trying to be a normal cat and all that. Which is mostly good. I just need to be hounding him to keep it, to take it easy, because he's recovering from major orthopedic surgery. Where is he? Luna's just like right here behind the camera. Maybe I can get them all three in frame. Oh, there's the band photo. Oh yeah. Lord of the dustpan and broom and air hose. Okay, cool. So George has one vote for Crazy Cat Lady content being wonderful. That's cool. Yeah, Jail Kitty is free. Yeah, I really like it when he's free. And I'm sure he feels the same way. And on Nexus has been good as quality source for steel or aluminum core jumper wires. Yeah, I think I got these from somebody random on Amazon or eBay, but same deal. It's just like when you buy from a random seller who has no incentive to give you good stuff, this can happen. But it's a gamble. Yeah, and then Samantha asks if I have to worry about the cats messing with the shop equipment, like chewing through the wires. Yeah, I mean, there's stuff I worry about, like, there's sometimes just like stacks of stuff for them to knock over, so like, it's this balancing act with pretty much everything, the wires and the stuff that I leave out and just whatever, of like me being kind of conservative with what I put out where, while also kind of paying attention to what the cats are going to mess up and trying to balance it so that I don't put anything where they're going to have it be a problem. But there's still stuff that I don't know how to keep them from getting into, like that red chair that Luna's sitting on. You may even be able to tell on this camera feed particularly that the side is kind of torn up, so they like tearing up very specific pieces of furniture, and that's one of them. And yeah, for wires, Tuco in particular does like to chew wires. Not all wires, so I don't have to be like protecting every single wire in the shop. But there's some specific formula of like diameter and like durometer of the insulation that makes them specifically appealing for him. So what I usually do is I kind of preemptively protect cables that would be especially bad for him to chew into, like power cables or like fiber optics or whatever. I mean, I don't have any fiber optics in here that I currently use. Like, I guess the only would be like audio, but yeah, for like the big power cables around here, I coat them in this like split loom crinkly plastic stuff, which isn't really any good. It's just like a thing that you can use it to keep the wires together, but it's also something that he just has no interest in chewing, so it keeps him off that. And so that's kind of my strategy. That's why you might see there's so many just cable snakes and yeah, and the more delicate stuff like these fancy oscilloscope probes, I just try to put them away when I'm not using them. Not that I've seen Tuco chew on oscilloscope probes, but it would be really bad if he chewed them even a tiny bit, Wow, look at all this peace. They're just hanging out all peacefully. I feel like I could go over there and try to interact with them, but that might just upset the whole situation. So maybe I'll just like hang out over here, wandering towards and away from the microphone, causing ambiguous phasing artifacts. Yeah, maybe peace was the wrong word, as Elman's is alluding to. It might be more of like a standoff than peace. Yeah, so with the wasp situation, I was just thinking about, yeah, I still feel bad about that. I feel bad about killing ants too. Like I've had to kill a bunch of ants. I mean, I guess I didn't have to. I guess I could just like transport every ant I find outside. But like when there's a whole trail of ants and I've got a dustpan and a broom, then everything seems to look like a problem I can sweep into the dustpan and the broom. Yeah, but like for I especially didn't want to harm them if there were any kind of beneficial insects, or like I try to be nice to spiders. I certainly wouldn't want to hurt a honeybee. So that's why I was especially, like, so I trapped it and was like asking on Twitter, is this a wasp? If all you have is a hammer, everything begins to look like a nail. I have some sewing equipment here, but not a hammer. Yeah, I've killed a bunch of ants. I'm sorry. I have mixed feelings about. I mean, obviously I did it and didn't feel good about it, so I guess that's obvious that I have mixed feelings. But I didn't see a lot of viable alternatives, and there was a lot of utility in it for me, and I didn't feel that bad about the ants, but I felt. Obviously, they had some feelings about the matter. Now, I do actually have some sewing equipment here. Like, I used to have some like random like hand sewing stuff, like, you know, needles and thread rippers and stuff. I think some of that stuff might have gotten lost in my last super chaotic move, but we should really get Cloud back on screen. He's enjoying the water fountain over there. So yeah, I think some of that sewing stuff might have gotten lost, but it was all like just really basic stuff that would be easy to replace. I made this sewing machine ages ago. It was like I took this just basic low-end plastic Singer machine, and I was trying to do some like plushy embroidering with it at the time, and I was just frustrated with how badly it ran at low speeds, and so I built this DC motor closed loop drive for it. And so I used this for a while, and then at some point I was living in this much smaller space and didn't really have room for it, and another friend kind of needed a sewing machine, so I gave it to her, and so she had it for a while, and then she actually kind of didn't need it anymore and wondered if I wanted it back, and so I was like, yeah, actually I'm in a bigger space now and I could actually take it back, so I've got it. Unfortunately, I'm missing the foot pedal for it, so I need to improvise a solution to that, or find, well, the original in this case wasn't improvised, because like the way the original Singer works was that it had like an AC induction motor, so there were some different ways. How was it? No, it wasn't. Yeah, I think it was an induction motor. Was it synchronous? I don't know. It was some kind of really cheap AC motor, and it was very bad at running at low speeds. The torque got just extremely low, and the speed was unreliable, and of course it was open loop. And the foot pedal had like a light dimmer, like a triac circuit that would take that AC sinusoidal waveform and just chop it at a different point depending on how much you were squishing the foot pedal. So because I was building a DC motor drive circuit for this sewing machine, I took the light dimmer parts out of that, but kept the circuit board and the variable resistor, and then just wired that out to a headphone jack. So the part that I would need to replace is also slightly custom. I was looking on Thingiverse to see if anybody just had like nice 3D printed foot pedals that I could use as a starting point. I didn't see anything quite right, so maybe that would be a design challenge, or I could just update the firmware so that I can use the optical encoder to advance the sewing machine, which you can sort of kind of already do. What a peaceful cat situation. Oh yeah, sorry, there was a couple of YouTube questions on YouTube chat that I'm missing. Yeah. Better yet, build some robot cats. Robot Wars is so yesterday. Start a new show, Robot Cat Wars. That was from Mike's Radio Repair. And then Glenn Roman asks, what happened to the leg? Which is a great question. I still don't know precisely. I tried to see if I could, so it apparently happened in the middle of the night. I managed to, through a combination of like knowing when I'd started seeing him limping and when he was fine, and then I've got like a couple of cameras around here that record 24/7, and so I could go back through some of that footage and just see, like, you know, can I actually find when he presumably jumped off of something or whatever and got his leg hurt. But whatever it was happened off frame, so I see him walk off the frame. He's gone for like hours, like most of the, like I think I saw him leave like late in the evening, and then the next morning was actually when I noticed him just hanging out in the bathroom under the bathtub, like nursing a bad leg. So yeah, I still don't know exactly what happened, but it seems likely that maybe he jumped off of something that was a little bit too high, or maybe he like got it stuck in some kind of crevice or something, like under. Like, I mean, maybe it's possible he was in the bathroom to begin with, and like there's some like plumbing there that's kind of weird. Maybe he got his leg stuck, but it seems most likely he jumped off of something. And it wasn't the server rack, because I would have seen it on the camera if it was the server rack. So it was something either upstairs or in the bathroom or in the kitchen, which are the areas that are off camera. Where is the cat? He is headed over to the bathroom. Let me see if I can get there with the cord I've got. Oh, this cord is not the longest thing. What is he after over there? Oh, now Tuco and Luna are starting something. Dudes. Hey. Oh, there's some food over here I didn't put away. Oh, yeah, he's... I was trying... Oh, don't be fighting dudes. Okay, maybe he's going... Dude. Sorry? Okay, maybe this is not gonna work out. Oh, yeah, you're gonna start getting soup. You're just gonna rip that flesh. I know that feeling. Okay, well, maybe I don't have to put away the food if I'm putting away the box cat anyway. Well, yeah, so stuff like that sometimes. Sometimes it's super peaceful, like he'll just like lie around for hours, but it's easiest, like I try to let him out and get some exercise down here when the other two cats are upstairs. So yeah, what was just happening there, I think he was getting in their business by stealing their food or something, and now where are even the other cats? Sorry. At least I don't think I'm bleeding this time. Let's get this camera unzoomed, at least. So I don't see the other cats. They might have just run upstairs. Oh, there's Box Cat. Sorry, dude, but we can't have you, like, jumping and fighting right now while you're trying to heal. Let's see if there's anything else I missed in this chat channel here. Nick John on YouTube chat says, cute cat. Yeah, they're all pretty cute. I'm especially fond of Tuco. He's my boy, you know. Christopher Metcalf in YouTube chat asks, what would you direct an older noob that's interested in toying electronics at a beginner level? You know, my advice, like my first line of advice, I guess, for most people at most levels is to find like interesting projects that you can devote a lot of time and curiosity to. because if you like, I think the thing in hindsight, you know, for whatever hindsight is worth, that's worked really well for me is just having specific things that I can get super interested in and devote a lot of time to and just really want to have a deeper understanding of. And so those things then give me the framework that I'll need in order to like do the reading and the experimentation that I need to actually get a better understanding of what's going on. I'm gonna ditch this other mic because we are back at the desk now, if I can remember the right button. Of course I would have left my beer somewhere else. What a tragedy. That's right, I put it down over there when I had to use my full attention to deal with the cat. So, yeah. Anyway, so the overall plan here is that we've got a refreshing beverage and some, at least for me, it's some time on a Saturday night. What better time to work on robots, right? And a desk full of parts here. In fact, so you can see we've got, if I can even get the camera straight. So this is one more winch. I've actually got one winch now that's fully completed, which is the one that you might have seen in the video that I released, what was it, last week now? So there, it's over there. I've also got parts in various stages of assembly. So over there, I should be recording this. So yeah, over there you'll see on that wire shelf a couple more mechanisms just like the one on the desk right now. And then on top, 3 more shells. I spent a lot of time this afternoon cleaning those up. The post-print cleanup on those is a little gnarly. Should have factored that into my design more. Oh, nice. And on Nexus says I need to get off my butt and build a 3D printer. That sounds fun. Yeah, I assembled my first 3D printer together, or I assembled it from a kit, and so it wasn't really building, like designing it or anything, but it was nice getting a sense for like how to actually set up all the parts at that level. And I'm sure designing a 3D printer would be especially fun. So, I'm going to grab the other couple of winch in progress assemblies in a sec. First, I just wanted to get like one of these set up for the next step. I keep finding myself in this pattern where I want to prototype something, I'll try it once, then go do that on the other 2. Kind of this fractal version of the thing where I made one winch and then I'm building the rest of them in a batch. Tuco and Luna are still trying to fight a little bit up there. But, well, this, I have to say, is the main plan for the stream. You can tell because I have a stack of bins here. These are like the essential vitamins, or at least some of them. The M3 nuts, a couple of different sizes of screws. So there's that. First I wanted to get to a very delightful donation that I received in the mail recently. And for that, a little bit of context. So, you may have seen these things before. I did a couple of videos on tablets because I find them fascinating devices, and I think they're fascinating to try to understand if you are just, like if you've used these. So these are like, if you haven't seen them, you hold a pen. I think the pens are separate right now. I just brought this over here. The pen, in this case, actually has like a coil and like a capacitor and a chip. It's like a resonant circuit. So it has basically a fundamental electrical piece that will resonate electromagnetic energy at a particular frequency, efficiently with a particular inductance. But on top of that, it's also got this layer where while that whole thing is happening, it also modulates a little bit of data on top of that to send back like button and pressure state. So I did this whole video on the circuitry inside here, and even kind of reverse engineering it a bit. This was where I did the ROM extraction over USB. So it turns out this has a kind of weird processor. It's this thing that I think it originally was marketed by Sanyo, and then it was bought by onsemi. It's called the LC87. And so it's like a weird 8-bit processor. I think it's like one of those 8-bit with some 16-bit features kind of processors. And it was all mask ROM or something equivalent. And I think one of these actually uses mask ROM, and one of them is OTP, because I have a couple of different versions of these. And here's one that I've opened up already. You can see some of the mods. Oh, this is actually 2. This is the kind of stuff I was doing to it. Anyway, so this is the processor that we found inside the tablet. It's that Sanyo / onsemi LC87. In this case, I originally tried to see if I could get the firmware out of it via a debug interface. There are a few pins that are reserved for debugging, but I couldn't find any documentation about how the debug interface worked. And there was some mention of this tool called the RD87, I think for remote debugger, and I even managed to find a copy of the program on the Sanyo or whatever website. So I could download this program that was actually the debugger software that I could use to like disassemble binaries and like maybe glean some more information about the chip from these, other than just what the sparse documentation had. So that was actually when I then went on to another side project of emulating just enough of that debug dongle, that RD87, in order to make some progress and then just like kind of fake out that software debugger enough that I could get past it and then use it as a disassembler to figure out the Wacom firmware in these tablets. So we went through a lot of work in order to extract the firmware, first of all, and then with very limited tooling, understand the firmware enough to make some interesting modifications and understandings based on that. Did I just use understandings as a noun? That feels terrible. I don't know why I did that. I think I got a drink to that. Anyway, so yeah, I've got previous videos that explain more about the circuitry, but in reference to this, there was that debug interface, that RD87 port, and as far as I can tell, it wasn't enabled on here, but that was just based on a bunch of like exhaustive guessing about what I could imagine the debug protocol might look like, and like sending it things that might be packets, and like disassembling the firmware that goes on the debug dongle. But then that didn't even turn out to be super helpful, because the debug dongle actually seems to implement that protocol substantially in hardware. So the firmware was just writing to a bunch of undocumented registers. So yeah, I hit a bunch of dead ends there based on just how limited the amount of tooling I had, and then just had to do something different. Like just had to disassemble it using the RD87 that I hacked up with FaceDancer, and then extract the firmware using that that side channel trick. So if you're not familiar with the side channel trick I used on this, there's a whole video on that. But I used how did this work? I used a so the Chip Whisperer is the Chip Whisperer Lite specifically is a really nice little FPGA platform. So it's a little hardware platform for doing side channel analysis with, you run some experiment on a device, and then you very carefully look at how much power it's using, or you run some experiment and you at a very specific time, you insert a glitch by just kind of like inserting like a very brief power transient into the power signal for the chip, or you can do something similar into the clock signal. So with this, I was actually using that Chip Whisperer plus an add-on that I developed that lets you send out very carefully timed USB traffic. So I would send it this USB command that would usually read back some information that was stored in that same ROM as the firmware, but was usually just like, I'm this kind of USB device, like a USB descriptor. And by glitching the firmware and causing it to mess up at just the right time, you could get that same chunk of code that was reading the descriptor out of ROM to actually read out the whole firmware, or at least enough of the firmware to be useful. So that was what I ended up doing, and it actually worked, surprisingly enough. It was one of those Rube Goldberg machines where it's like, oh, this could fail in any number of ways, and you could bang on it enough and it finally actually works. So anyway, that's like some brief context for what I did on these tablets previously. But obviously I still have this hardware around, and there might be some other neat things we could do with them. Actually, there was a whole thing that I got working and wrote an article about, but never actually edited a video about. So you can find an article, I think this was in POC or GTFO. There was an article about using one of these tablets in order to read an RFID card. So if like just you leave your keys on top of your graphics tablet when you go to lunch or something, and there's malware on your computer, the malware on your computer could install some special firmware on your tablet, which would then use the analog circuitry in your tablet to power up the RFID card and read the ID off of it. And then somebody outside your building clones it and gets in. That's the theoretical attack model. Of course it's ridiculous, nobody would actually do that, they would just follow someone in the building. But it's like an interesting thing to try to think about, is like, if you compromise a microcontroller system that has this particular kind of physical interface to the world, what can you then achieve with that? And so it's a little bit like a lot of the recent security research that's gone into software-defined radios. But this is just like it's almost like a near-field version of that, but it's even more specialized because it's just for tablets mostly. But because so much of it is implemented in the firmware, if you have control over the firmware, you can change a lot about how the protocol works. You can change the modulation frequency. You can like sample it differently. You can change which pattern of antenna on the board are actually radiating at what time. All of that's controlled in software. Hey, Fuzzo. Oh wow, I was just checking on the chat and it looks like there's a pretty amazing LED project going on. 2,000 WS2812 LEDs, and then there's also a pretty amazing CNC, it sounds like. That's pretty cool. I'll have to check those out later. There's always so much going on in the chat that I don't get a chance to see real time, but then like if I have a chance to scroll through the chat later, I can catch up on some of it. Oh, and I was also trying to catch up on the YouTube chat here. Oh. I think maybe I answered the questions here. Oh yeah, cool. I think we're good. Let me make sure I can actually see these windows. LJ Otep in YouTube chat says hello. Hi there. Always good to see new folks. This cat here is off the hook. Oh, don't knock over the beer. It's okay. Anyway, I should stop holding you all in suspense here. So, that was the context, and then we have this thing. So this was a delightful gift here from Jay Carlson, who was curious. He had some extra hardware that pertained to this project that seemed like it might be useful for future investigations. And I was like, yes, this is amazing. I would love some of this. So, wait for it. Oh, yeah. Does anybody recognize that name, TCB87 Type C? This is the elusive thing. I was like Googling for this thing. Nobody had it in stock. This was the thing that the debugger needed in order to talk to the chip over this undocumented protocol. So like if I had one of these, I could reverse engineer the protocol, or I could just use the debugger. But Yeah. So yeah, this is amazing. I'm kind of curious to see what's actually inside this. So this is just going to be like a really quick unboxing right here. I think we might take a quick peek inside here, but I think I'm going to save this and the TCB87 stuff for a separate stream. But we just got to take a quick look inside here probably. Because my hunch, so one of the kind of dead ends that I did end up spending a lot of time investigating when I was working on that tablet project was that it was pretty easy to find the firmware image for this thing because it's packaged with that same RD87 debugger. And so because I had that firmware image, and I then developed a way of disassembling that code, even though I couldn't find a document on the opcodes, by emulating that debug dongle. Then once I got to that point, I could start using that disassembler that I'd cobbled together to start disassembling the firmware for this thing and trying to look for, well, how is this actually communicating with this undocumented debug port, which is like some 3-wire thing. But that was when I ran into what seemed like just more custom hardware. And so if that was right, then I would expect to see this actually having kind of a custom variant of the chip. I forget what they called it, but I found the actual part number in the firmware. It was like, I think it was like a W1 suffix or something like that, W something or other. Yeah, let's crack this open. Okay, well, unboxing will continue in a sec. I just want to open this, because, like, opening, man. Gotta get inside this. Is this a Phillips head contraption? Tuco is just right here on the desk, and I'm tempted to move the camera, but it looks like he's about to relocate. This surprisingly has chunky old Phillips head screws. Have we even looked at the top of this thing? All right. I'm going to do the whole don't turn it on, take it apart thing for once, but I'm actually going to look at the top of it first, which might help. So the actual button here is reset. Is that a button or a light? It looks like it might be a button. Can I push it with something pointy? That is a button. So we've got one button that they don't really want you doing much with. Maybe that's for reloading the firmware on the dongle. And then I assume this is target reset, T reset, and then activity light. I saw the code for this activity light in the disassembly, so that's reassuring. And then a chunky old USB Type B connector. Okay, not much going on. And then there was a little wiring harness for this, which I don't know why there are so many pins, but there were also some documentation CD-ROMs, so maybe we can find some pinouts for this on there. I couldn't really find downloadable documentation, but the CD-ROMs might actually help. Oh, and my highlights are so blown out on this webcam right now because this shop is so dark. Aw, sorry. I was just noticing Kate Timken's comment. That's still my representative test for anything I do that might slow down face dancer. Will it still run scanlime's emulation code fast enough to be usable? Yeah, that was my. So I had done some like simple stuff with face dancer just to play with it. For anyone who doesn't know, face dancer is a tool that was originally by Travis Goodspeed, I think, and then has been maintained by some other people, and now Kate Timken has been working on it. And it's basically a tool for writing your own USB devices in Python very straightforwardly. So it's based on just kind of gluing two USB chips together, one that knows how to do USB device emulation and one that's just a USB serial port. And so it's not efficient, but it's just a really basic way of making a USB device that you can program. And so that was a nice way of just making a Python script for emulating this thing. But I tried that, and it turned out to be actually way too slow because, you know, of course this RD87 thing is not the most optimized thing either, and it's just making tons of tiny, tiny USB transactions for all the memory reads that it's doing from what it thinks is the target, where I'm actually substituting the binary that I want it to disassemble. And so it was just too slow to be usable. I was just getting frustrated with it. So then I tried a variant of Face Dancer called Rasp Dancer. And I'm spacing on who's responsible for that. I think it's somebody who regularly contributes to POC or GTFO also, but they had a variant of Face Dancer that where they used the same USB device chip, but instead of connecting it to a microcontroller and a USB adapter, they replaced that part of it with a Raspberry Pi. And you can use like a Raspberry Pi 3 with fast GPIOs and actually have a decent USB peripheral there. Okay, we are not going to be screwed over by Servo AF. We can just take this off now. Oh, that's nice. Is this fully buffered? It might be fully buffered. It might even be fully level shifted. I assume these are level shifters, these little dudes. But let's bring the camera in lower. Maybe even, might even be time to do microscope in a sec. '87OW. Is that, oh man, I feel like I've got to go check my reversing notes and see if this is the same model number I saw in that firmware file. Because this is like, this chip right here is unobtainium as far as I'm concerned. Like, that was the thing that I just could not find, is like the special revision of the silicon made from this weird microcontroller just to program other weird microcontrollers. Yeah. So this has, as far as I can tell from the reversing I've done, this chip has like a special purpose serial engine that knows how to speak this like kind of specially weird kind of bidirectionally SPI thing. I mean, the pins weren't really labeled that well. I think it was just like debug 0, 1, and 2, but I think it's going to be some kind of like bidirectional SPI. I think the pins do have tri-state buffers. I forget why I remember that. There was some, oh yeah, there was something about direction in the firmware, but so many dead ends in that reversing. That is an LV125. I think those are level shifters. LV07. Yeah. Well, that's cute. This is nicely made. TCB87 Type C. Oh man, this just feels... I can't believe I'm actually witnessing a TCB87 Type C with my own eyes. Oh, it's even got the Sanyo logo from before the OnSemi acquisition. Oh, and we've got some test points up there. Is that for programming this firmware, I assume? Because I assume it's got a way of in-circuit programming over USB or over something more low level for like the initial download. Oh, Arc AIN6 on YouTube chat says hiya. Hello. Is that a chemical formula, or I feel like half the acronym things are chemical formulas and half of them are like anime references, and then like, you know, the other 50% of course are something completely different. But I'll try my best. Oh, this is going to be super annoying. Great. So this has tiny little spacers which will pop out as soon as you take this apart, and then that's just self-tapper. That's not the greatest plastic case. Oh, we got some, are these regulators? Nothing of consequence really. I assume that's a 3.3 volt regulator. Why do we have two of them? Those are the same, right? That BBM, oh, we should microscope this. Oh, 88M33T. and S33. Okay, different chips. So these could be different voltages, or these could just be transistors. This says IC though, IC2, so I'm guessing these are regulators. Do we see capacitors on the other side? Yeah, okay. Regulator town, I think we found that. Okay, well that's cool. I think that's probably about the extent that I will dig into this right now, but let's put it back together. That's amazing. It's a TCP87 Type C. Oh, how is this even meant to go together? I think we have to put the bolts in and then stack the spacers. Oh, maybe we can just put these in with tweezers. Oh, cool. Okay, Timken has looked up the part number as a fixed 3v3 regulator. Great. So that is just burning off a couple of volts to keep the micro running nice and happy at 3.3 volts. I was listening to a bunch of embedded FM this afternoon while I was cleaning 3D printed parts, and I like how she asks all of her podcast guests these lightning round questions that are just like a bunch of fast questions that she just expects fast answers to. And one of the questions is usually, what's your favorite voltage? And I'm not really sure what I would say actually. It would probably have to be 3.3, but oh man, if I was more of a mobile person, I would maybe pick 3.7. But I don't know. And then there's 2.5 is a nice one too. And then some people would pick like 240, which is also pretty respectable. We have a vote for 1.8 here in the chat. That's pretty good. Oh, okay. So, okay, Arc AI N6. I see. They're in YouTube chat also, so they're the same person as a non-Nexus, and it's a abbreviation of a longer name, which makes much more sense. From the days when NICs were truncated by BBSs to 8.3 characters. I was never really into BBSs, but I really, I was like, I should just shake it and get the screw out. No, that was the worst thing to do. Can I salvage this? I can still see the washers there. I do remember IRC having some limits, but they were kind of longer than I usually cared for my NIC to be anyway. But some people I know ran into them. I think this is salvageable. I've got one back already. I should save the screw in there while let's up the ante here. So I fixed one washer by nudging it back in. The other one is kind of bad, but I think I can salvage it. This is not a good case. If I plan to actually ever disassemble this much, it might be fun to 3D print something. But I imagine this will exist mostly in the fully assembled or a rat's nest of 30 gauge wires states of existence. Oh, this is infuriating. Oh, I can see it now, so I've got to get it to roll somewhere I can grab it with the tweezers. Oh, I don't know if I can do this on camera. Oh, so I'm trying to just like poke it. How do I explain this without getting frustrated about the whole situation? Well, I've got it where I can grab it with the tweezers. I don't know how much that helps me, but I'm going to assume it does, I think. It's probably starting to get to the point where I should just take it apart. But now I've got a fun little game, like a little physical dexterity challenge, right? Some of you probably know the feeling. I thought I had enough purchase with the tweezers to lift it back up onto where it's supposed to go, but maybe not quite. Okay, I'm just gonna take this apart. I don't like this case design, I have to say. I mean, it looks like this is just a very off-the-shelf case that they didn't really spend any effort on. So I guess I won't be too heartbroken if I totally wear out these self-tapper screws and have to design a new case. It would be great to glue these down. Maybe that would be a thing to do. I mean, super glue is tempting, although that'll easily, like, unless I let that dry before putting the screws in, I might get the screws stuck. I've got E6000 here. In any case, I don't really want to, like, align these carefully with some kind of, like, I guess I could put the screws in, glue these into place, back out the screws, then put it all together again. But that's so much extra wear and tear on the self-tappers. Let's just try to not screw up. This seems better. Unless I just make a colossal mistake. Again, that was almost bad. I think we're good. I think we're fine. Okay, cool. Well, adventures in LC or TCP 87 teardowns. More of this a little later. I'm gonna dive back into this strange processor. Somebody was, oh, that's right, I was listening to that, to Jen and Alvaro's unnamed embedded engineering, the unnamed reverse engineering podcast, and they had, oh, I'm forgetting his name, Dominic something? Anyway, he, oh, where's it going with this story? Remembering names is pretty much the worst. There was a point here. I thought it was about debug adapters. Oh, maybe I'll remember it in a sec. Oh, he was doing a lot of things himself. Alright, well that's reassembled. Here's a quick look at the cables that it came with. Oh yeah, the signal path does great teardowns, just to randomly notice Derek's comment there in chat. Ooh yeah, so we've got a couple of different wirings of this. Right! So there were a couple of different debug protocols. I think this is like a legit one-wire version of the protocol. And it's like power, ground, and one signal wire, I think. And then this was just some other protocol which I think had a separate clock, but maybe the documentation actually talks about this, I don't know. Alright, did this have a point? Where else can we go with this? There was a USB cable. I think this is a normal USB cable. There's another board, and these two CDs. There's the LC87 installer and Easy Micon, which I think is their weird compiler demo version. I think I think this might be downloadable, but actually some of these, like there might be some overlap between what I already have and what's on here, but we'll take a look at these sometime. These are just CDRs. See if there's anything new. I think there might be like a demo project though, because this is actually a, so this might have also been something that came up in an earlier stream, but during this whole saga, I bought the one LC87 eval board that I could find, but it just came with nothing useful. Like, it didn't come with even a way to program it. It just came with a way to run like an example application that spoke a couple of serial protocols. It was terrible. So this looks like it might be a better development kit. Oh, wait, is this more unobtainium? 870W. I wonder if this is another programming adapter. That would make sense, right? I think that's the same chip. I'm not going to open it back up, but maybe, you know, like later I'll be able to check in the footage. Maybe somebody else will be able to tell me if that's the same chip, but I think that's the same suffix. Anyway, that might be cool, having two debug adapters to toy with. Especially if they're both reprogrammable debug adapters. Might be able to figure out how that hardware works. And then this is an actual target board. So what's the suffix on here? Hey, Tuco. Let's take this to the microscope. Oh, Tuco is interested in this cardboard box. Tuco, do you like CDRs? Oh, nice. Michaela in chat has a cold plate set up for chip decapping that looks pretty fun. Mike's Radio Repair says super glue is your friend. Another trick, put screw in board, slide on spacer, and apply a drop of beeswax to hold it together. Oh, that sounds interesting too. I don't know if super glue is my friend. I've used super glue a lot, but I think we have kind of a tense relationship. I have trouble with super glue vapors recondensing on nearby surfaces. Less in the way. '87F. Okay. I don't remember what all the suffixes are, and frankly, I mostly just remember that they were really weird. Like, there's one that has USB, which is the one that well, actually, the one on the Wacom tablet, I think, might have also been another unobtainium custom silicon thing. Because as far as I can tell, there was a custom unit in there that just did the sequencing of the multiplexers the way Wacom wanted it to. And it's got like a part number I didn't see anywhere else. So I think that because they were a semiconductor company, they just liked spinning custom versions of this for clients. So 871F. Anyway, this is just like a target board that has some passives and a button and a USB port. So I guess this variant does have a USB controller, I assume. Looks like those go... Yeah, USB goes through that header and then into those pins. So yeah, I assume this variant has USB on board. If I wanted to do something interesting like, so I can basically inject my own code into the Wacom firmware if I want. And, oh, cool, somebody else has a blow up of the chip from earlier in chat. Let's get that handy. Oh, let's come back to you in a sec. Okay, so this is... Oh, that's not what I wanted. (870WHST) Whoost. And then from the microscope, what do we have? We have a winner, so we do have 2 debug adapter chips here. So I don't know if this is completely specific to the debug adapter. It might just be, you know, that they threw that peripheral onto some other variant of the chip that's also used for a bunch of other things. It might be that it's not even a debug adapter peripheral. It might be something that's more general purpose. It looked pretty application specific, but that's just my guess from a bunch of reversing. But it also just doesn't seem like this company was shy about making new versions of this chip. So, anyway, I think that's all we've got for now. I'm going to put this on the shelf of things for future streams, because it seems super interesting. But I think right now I want to get back to building WinchBot. Oh neat, Mike's Radio Repair from the YouTube chat adds, you can get little bars of cosmetic grade beeswax on eBay. It's very soft and pliable and inert, so it's not conductive. It's used in radios to pop crystals for temperature stability. Oh, I think that might be, I remember seeing something kind of waxy in like radio coils in the past. I wonder if that was beeswax. I think the next step on this project might just be slurping off those CD-ROMs. That might make a fun stream too. Okay. Well, back to some roboting. So, where we left off this project, we had 3 more of these mechanical assemblies completed. So, well, I can just show you the assembly. This was actually kind of hard to run before because it would tend to want to take itself apart, but now that it's actually bolted together, I should actually be able to run it. If I can attach it to anything. Maybe I'll just sit this on its head. So I'm going to run this at below maximum voltage. This is a 24 volt motor, and I think I'm going to put like 5 volts through it. But just to... Oh, I have a vise within arm's reach. Maybe that will help this situation. I mostly just need it not to fall over, and maybe I can even focus the camera on it. That would be great. Oh, having it motor side up was actually more useful for this shot. that might do. Better lighting for sure. Oh yeah, I haven't greased any of these gears yet. Maybe it's a good time to do that. No, actually, I should probably grease them as late as possible, right? I don't know, I'm not gonna be like sticking my fingers in there, but famous last words. Alright, 5 volts. Let's just start with that. More kind of wobble on that motor gear this time than previously. That's not the best. But it seems fine. Let's give this more voltage. Careful, Tuco. He's climbing around the power supply. That is 12 volts. Yeah. I think we got an alright thing. The rollers feel fine so far. Anyway. More of an illustration than anything. I think it makes more sense to do the actual mechanical spot checking and lubrication a little bit later, once we've assembled some of the electronics. But that's kind of the state we've got it at right now. It can move the spool, we've got rollers, all the sensors, well, both of the sensors are mounted, but not electrically connected yet. And I think the next thing I wanted to do was to just make this a little easier to handle. I just wanted to put the bottom on the thing that attaches through these 6 holes. And that kind of has to happen at the same time as assembling the emergency stop switch, the way this thing goes together. So that actually becomes the next step. These emergency stop switches are super cheapo ones from eBay, which I saw on Big Clive and I thought were alright. They're kind of alright. They, it turns out, are not made with great materials, and so the resistance is higher than I would like. And so I decided not to trust them with anything high current or high voltage. So instead they're actually switching the 24 volt power that runs the control electronics, which seems pretty effective. But the next step here, I cut some wires already. I was going to put these in the screw terminals and then just test each of these e-stops before I use them. The way I did this before was to have them power a light bulb and then just measure the voltage drop across it. So I think we're just going to do that again. I think I do want them coming in the side. I designed the mechanical interface for these fairly tightly, so like I mean, not like there's, you know, too little clearance. There's a decent amount of clearance, but I don't think you could fit like a different type of switch in the same cutout easily. We are not very servo AF here. I should at least... maybe we should try that. Oh, I think the printed gear ratio should be exactly 2:1, if somebody's asking. And that was partially something I worked out based on like how much margin I have for RPMs on the motor versus the actual speed that I want the robot to move at. And then some of it was just based on the sizes that I had available to work with, and I just kind of picked something that seemed about right. haven't really iterated on that aspect of it at all. I just picked something and it seemed fine, and I've been going with it. I did iterate on the gears as a whole once. I made something which was largely the same as what you see now, but the whole thing was a good bit thinner, and I tested it, and it was probably strong enough, but not as strong as I would have liked, so I like literally just doubled the thickness of the whole thing. I'm just going to pick 3 of these arbitrarily to wire up, and if any of these seem to underperform, we'll use the 4th one, otherwise it'll be a spare. So these buttons, the idea is if the robot is doing something bad, like catching fire or pulling someone's hair out or starting to tear itself apart, you can just bonk this button, and depending on the failure mode, it should at least have a good chance of stopping whatever's going wrong. One disadvantage of wiring the button the way I am, where it doesn't actually cut off the AC mains power for the bot, is that some types of electrical failure, you'll still want to just like yank the cord out from the back. But I think given that I'm using a good quality power supply with a fuse and the lower current stuff all seems to have fairly reasonable protection limits. Like, I don't think I'm that worried. And then, like, this will have the role of cutting off power to the control electronics, which will cut off power to the H-bridge. If the H-bridge itself is still failed in a way that's causing it to short out, then the motor could still be running, so then you might need to yank power. So those are all suboptimal. You could fix them with better design. There are a lot of designs that are better. This is just the one that happens to be the current iteration I'm using. You know, you could design this with a big old relay of some sort, although you have to be careful about the relay contacts not welding together if the motor is like super stalled. So if I was designing a custom circuit board, I'd probably just throw in a handful of additional features just to, you know, monitor temperatures and stuff like that. But right now it's kind of trying to keep this simple and just throwing together a couple of off-the-shelf boards. If this is something I end up making another prototype of, then I'll definitely design a PCB and make the printable parts a little easier to produce with less cleanup. I'm really tired of cleaning up brims. I mean, I'm finally done with all that. That's just what I was doing most of this afternoon. Alright, so we have 1 to put aside, 3 to test. So I'm just going to get some clippy leads for the multimeter here so that I can measure voltage, Kelvin style. So cold. This is just, for a little bit of context, we're assembling these robot parts that I've actually got a video, if you haven't seen it, that explains this particular robot that I'm making. And then I'm making 3 more of them so that we can have the full set of the 4. And this is just me testing these cheap emergency stop switches to make sure that they will be barely good enough for this project. And I've already done this for the one that's in the winch that I built, but this is the next batch of 3. So let's just do one of these at a time. Oops, dropping them will definitely help them work better. Cool. And clip these on the wires. And I'm going to set the power supply to 6 volts to match the light bulb that I have here, which is my dummy load. Something kind of like this. Let's maybe get a slightly better view. This would be better if you could also see the current meter. Hmm. 6 volts. This is not a 6-volt bulb. What's going on here? This is just bad connection on the socket. Hey Zach, streaming. How are you? Good. What is going wrong here? This has got to be the simplest possible thing we could be building. Is this just a bad alligator clip? Let's narrow this down here. Power supply seems to be on. Oh, is this bulb just not a 6-volt bulb? And I'm not even, I was expecting I would at least see it glow a little bit, but maybe I just need to crank this up. Okay, it is officially cranked up. There we go, finally. Alright, so that is 12 volts at 200 milliamps, which, you know, seems like a reasonable load to test this at. It's like not too far off from what I'm actually going to be asking this to do. That's really not great, right? But it'll do. See that? Okay. This is not great, but it is fine for this application, and it's consistent with what we were getting on the other switch. So let's just make sure they all behave about like this, as bad as it is. Nice. This one seemed a little better, but same ballpark. Maybe about the same. All right. Oh man, the most exciting thing, testing switches. Oh, nice. Oh, I'm sorry, I have so much trouble with this name. Plop, splip, splat, doodle? Sorry, plop, splipadoodle, something like that. Says in YouTube chat, there's something deeply satisfying about how the bulb is illuminated as the safety is released. Yeah, I enjoy that too. When this is actually wired up in the winch, there's a similar effect where the green LEDs on the microcontroller board turn on. Anyway, this one seems fine. If not the best of the bunch so far. I guess there's some similar variation. Alright. Let's put this setup aside and do some actual mechanical stuff again. Alright, so these are the two halves of the mechanical part that go on the bottom of this winch. So, kind of the counterpart to this fits around the motor. Oh, yeah. Elmans is asking about the plating on the contacts. Yeah, I'm just assuming they're not made out of good metal. Like, I think usually they use something like phosphor bronze for that. And this might just be like, I don't know. I think it might be at least copper. But yeah. Mario says we can't keep testing the emergency stop button for the satisfying clunk. It is satisfying. Yeah, actually, I mean, everybody knows about Big Clive already, right? His videos are very satisfying. But he's got a video on some of these similar switches. So they're actually a modular system where there are some different pieces that go on the front and on the back. They can have normally closed and normally open sections, and you can stack them. And it seems like a fairly nice design. It's just a shame they didn't seem to use nice materials in this one. Alright, so something like this. You can kind of tell how this works based on, put these together, the two halves made up, and they leave this kind of bulgy pocket for the mechanical core to fit in. So that bulge lines up with this bearing support for the vertical roller. So in fact, these go like this. Oh, I'm also realizing another dependency. I need the other cable that fishes through here, because otherwise it gets really hard to fish that cable. So I don't have to wire it, but I have to at least fish it. It'd be nice if I could test it, but I could refish something later. Oh, this definitely could have been easier to assemble. It's done. Is that it? This is where I'd be putting my hands entirely in the lubricant if the gears were already lubed. Oh, this is kind of fitting, but not entirely. There we go. That's how it fits. So like this, but with the switch in there and with all the wires going through. So, and you might wonder, like, well, how does that even work with the switch? You have to put the switch in place, but not tighten the front piece, and then you put these screws in, and then you tighten the front of the switch. It's very specific. Yeah. So, ribbon cable. This is a different order than I was expecting to do things in, but I guess we could just detour to the strain gauge amplifiers, because maybe it is actually the thing that we need to do next. So here's what I'm talking about. There are two sensors. There's the position sensor. Internally in this can, I still have not opened one of these, but I'm assuming what's in there is a little disc, either a clear plastic thing or clear glass thing with a bunch of marks made on it, or a piece of metal with a bunch of cuts etched into it, and then a phototransistor on one side that senses light that the LED on the other side sends out, and then two of those offset by half the distance between the cuts, so that when you rotate this, you see these patterns of flashes, either one first then the other, or vice versa. So a quadrature encoder. So that's how we measure the cord's progress. And then we have the strain gauge. And the strain gauge is actually a piece of aluminum, and you'll see that it's had a lot of its interior machined away. And it's just got some metal on the top and some metal on the bottom. Not much. That's part of why it's rated for 5 kilograms and not more. And you might notice that there's like what looks like maybe a blob of something white with some wires underneath. So there's actually a very, very thin foil that's been bonded to the metal. And that thin foil forms a resistor. It has like a squiggly pattern etched into it, and it's made out of some material that has a constant resistance over the ranges of temperatures and properties that we care about. And it has one on top, one on bottom. And the wires come out on this side, where you have two wires going to... They're actually arranged in a bridge, just like a diode bridge and a bridge rectifier, but now it's a bridge of resistors. And so you can actually apply power to two of these wires, and then use the other two wires to measure the balance between these two resistors. So that gives you a tiny voltage that corresponds to the tiny resistance changes in these two different pieces of foil. And so what happens is the tiny stretch in the metal as the force is applied to this pulley causes those tiny foils to change slightly in resistance and get completely out of focus, which is fine. And so we have this tiny voltage to amplify. We also have a requirement for a fairly steady power source to energize that resistor bridge. So that's what the circuit board that goes right here does. Actually got these in a kit with the strain gauges. This is basically what you would buy off of eBay if you were trying to build your own digital scale out of an Arduino. You got some strain gauges. And these are cheap too. They're just like a couple dollars, I think. So this is the same thing you'd find inside a digital scale. You might find like 2 of these, because sometimes it's easier to have multiple strain gauges than to spread out the force mechanically. And then Nexus in chat says, I used a metal bar like that in a scale once, came with the pressure sensor put on it. Well, that's interesting, because like usually I would think of this bar as being the pressure sensor. But you're saying there was a separate thing on this that was more like the pressure sensor? Actually, I happen to have a couple of other styles of this handy. Let me grab some examples. Wow. I thought I knew where they were. Maybe I'm failing. They look a little bit different. The ones that I've usually seen in digital scales are almost like a single chunk of metal that's been stamped into like a U shape. And then, so they've got like a tab that kind of flexes in the middle. And then you have one of those in each foot of the scale. So I had some of those. I thought I knew where they were. Sorry. But it's internally, it's kind of the same idea. It's like on the metal, there's a very thin resistive foil, which is very delicate, but it's like adhered to the metal so that as the metal flexes even a tiny bit, it flexes the foil and actually changes the dimensions of the resistor. So just by causing the physical material to stretch a little bit, it changes the resistance. Oh, that's interesting. It sounds like that description is something a little bit different. They're saying the bar was bifurcated with the sensor between the slit, and as the bar flexed, it did so unevenly, putting pressure on the sensor. That sounds like an interesting way for the scale to mechanically divide the force and use... So like, for example, if I had this 5 kilogram sensor, and I wanted to use it to measure something much, much heavier, then like I could, for example, you know, put it on a lever or something that would divide the force into something smaller. And you can kind of do that pretty arbitrarily. So I've seen relatively small strain gauges in something like a full-size weigh scale, just have a lever. So then these came with these HX711 breakouts. So this is what goes there. These require a little bit of modification too. So that might be good to do when we actually have the software set up so we can test them. But anyway, you'll see that we only need 4 pins here. So on the left side there's, I should just take this out of the bag. Yeah. So this is the HX711. It is an all-in-one strain gauge amplifier and analog to digital converter and power supply. So we've got kind of an SPI port on the right. It's close enough to SPI that I can use an SPI peripheral to drive it. It's a weird protocol where you sort of give it a sequence of clock pulses, and the number of clock pulses you give it determines what mode it samples in. And it also uses the state of the pin to signal whether it's ready. But anyway, I've talked about the software that samples that before, and we could do it again some other time. So on the left we have the excitation voltage. This is actually a regulated power supply that's supposed to be very smooth to provide the input to the strain gauge bridge here. So we'll want to actually add some capacitance there. There's supposed to be a big storage capacitor there, and they left that off on this board. So I was just dangling off a a radial electrolytic off the side, so we'll want to do that. There's also a trace I have to change up here to change the mode from 10 samples per second to 80 samples per second, because I just want faster sampling. But otherwise, these boards are pretty good. I think right now the thing to do is to focus on mechanical and just run the cable. So I just need a ribbon cable with 4 positions where I can identify one side, and then I think we can go on. Maybe, what ribbon cable should we use? Oh, so this stuff. I got this stuff at an electronics surplus shop so long ago. This Belden flat cable. It was like, how much was this? It was like $10 for 100 feet or something. Oh, from Weird Stuff. Yeah, some of you might know what that sticker means. $10. Anyway, I've been using this as my source of cable for a while. Unfortunately, the insulation is starting to feel a little bit gross, but we won't have to touch it much on this project. One advantage of this, though, is that all the wires are easy to tell apart because it's rainbow. I'm just gonna try to use the longest piece, and just because I need such a thin cable. So this is very thick ribbon, and then I've been subdividing it. This stuff actually should be pretty good. The insulation is not amazing, but the wire is alright. I'm just going to take plenty of that. Elman says those high-quality 3-strand aluminum core wires with premium oxide-coated connectors. Yep, that's what we got sometimes. Aw. More kind words from Prior Talks in YouTube chat, who says, I love your work. Oh, thanks so much. Let's put these aside carefully. The strain gauges are one of the more delicate parts, I think. It is just like very thin resistive foil, and then just a blob of silicone covering it. All right. Let's just put some tape on there so it doesn't get lost. If this gets stuck, then we have a problem. So we don't have to use the same color scheme everywhere, but it might help. I mean, given that I have this box of rainbow wire, I'm used to using random colors for ribbon cables. Okay, so now we're on the bottom. Can I stabilize this? This thing, before it's assembled, is just always trying to fall over. It's got just such a weird shape. So, now we come to the e-stop switch. This is actually designed to go in very specifically with one wire of the e-stop switch going through each of these holes. Like that. And then this we'll want to open up so that we can adjust it. We can even take off the front of this switch a little bit, which might help. Oh, that is tight. Why is that tight? And it's, oh, it doesn't feel like it's made of plastic that's strong when it's that tight. Oh, geez, yeah, you're all counting down for me to spill this beer. Oh, that's a good question from Brian Rosales in chat, who asks, anybody following this as a DIY? Yeah, I'd be curious to know. I'd be surprised, because this is pretty intense. I mean, anybody following along is going to have their 3D printer chugging along with mine, but if anybody else is working on something similar, I'd certainly love to hear from them. And if anybody else is trying to actually build this, then, like, I would certainly love to hear from you. Like, we're probably going to be finding out about the bugs at around the same time, right? Alright, so there's a gasket here. This is unnecessarily complicated, since I don't think any of this is even remotely watertight. It's probably barely dust tight, but there's a gasket anyway. I'm sticking it behind there. I think it'll at least hold it snug, at least. And then there's this yellow flaggy thing that just says emergency stop. So this is what we want. The wire going through the hole, screws are nice and snug, that's lined up. And then the other half just threads together pretty similarly. So hard to fish this through and hold it in the right spot so that it's in focus. Sorry. I think that's roughly what we're going for. You might be able to see the wires back there. Great. This is partly because I originally designed this before I understood how bad these switches were. I mean, obviously. And my hope was to use these for cutting off the AC mains. So I figured that those terminals might actually be live with 120 volts. So that's like why I did all this extra attention to keep them insulated behind this extra layer of plastic. And then so I was assuming I wouldn't use this side of the switch, but then that side of the switch, you wouldn't actually be able to poke through and hit those terminals. Like, it would be covered up. And now it's just an extra layer of stuff to go through. Oh, is Tuco in frame? If you're talking about the cat that's in the cage there, that's Cloud. It's not Tuco. That's a kitty that I've been taking care of, who has a... Well, he's doing really well, actually, but he had surgery recently to get his broken leg repaired with metal plates and bolts. Alright, so these two screws, I think, are the next step. If we were being super professional about this, I would actually check the CAD model to see what these are supposed to be, but I'm pretty sure they're M3x35s. I think when in doubt on this design, it's an M3x35. I think that's just how I roll. Oh man, the finest silver tone nuts you can order from Amazon Prime. I really hate ordering hardware on Amazon sometimes. It's fast, but they won't even tell you what metal it's made of half the time. These nuts seem to work. Oh, ISO Island is asking how many cats do I have. Usually one, but I'm also cat sitting for these two critters who are going to be homeless if they didn't have someone to hold on to them for some time. I think it was originally supposed to be a month, but now it's probably going to be a bit longer. But especially since things just got complicated with this surgery, like, I don't know. And then you know, the person whose cats these are was moving in with someone who themselves is looking for housing, and then this hurricane happened, which affected stuff for them, and I haven't heard from them recently, and I should check to make sure they're all still alright. But I haven't obviously been super involved in that process, or I would know more about it. I've mostly just been helping out with the cats and talking to them occasionally. I mean, I talk to the cats a lot, but I talk to the humans occasionally. That's too big. And on Nexus is saying they're my cats. No, they're not my cats. Like, I talk to their cat mom fairly regularly, and they're quite interested in having these cats back. They just need, like, a place to live first. They're not my cats. I'm happy to care for them, but they're not mine. Oh, nice. Mike's radio repair is signing off, but they're headed out to do a transceiver alignment on their Yaesu radio. They enjoyed watching and wish us happy winching. Well, that's pretty great. I will try to winch as happily as I can winch. Somebody was talking about the wickedest winch, but and like what side of the room it might be on, that kind of thing. But so far, my experience with the winches has been pretty happy and not very malevolent, as far as I can tell. Derek has a cute suggestion. I don't know what that is. I guess it's from a show I'm not familiar with. I think I need to poke the nut down in there a little further. Yeah, actually, I was hoping I would have some more design freedom on how to put like a logo or a face or something like that on the flying part of the bot. But that design ended up with just a lot of mechanical constraints, and right now the state of it is that I know how the top and bottom of that are going to look, but I haven't designed basically the skin of the robot. So it's got like 2 carbon fiber cylinder bones and then some electronics that fits around that. But I was planning on having like a skin that fits around all of that, like a cylindrical paper or plastic skin. And that could have all sorts of looks. And I was hoping I could incorporate that Suco Flyer logo, the one that you've been seeing on the web app that Misty drew a while back. That one's been, like, if I can actually have that on the robot, that would be great. I can't tell how close this is to actually threading. I think there's some junk in there between the nut and the bolt. Oh yeah, I saw Island is asking about the big 3D printer. Yeah, this 3D printer was not cheap. The bigger ones do tend to be more expensive than the smaller ones, although like I got this one several years ago now, and there are just so many more options for 3D printers now. And as Anal Nexus is saying, like you can DIY large 3D printers now. Like for somebody, like for a manufacturer who's trying to sell a large 3D printer, it's really hard because you need to deal with a lot of materials and shipping and warehousing for all this stuff. But if you're doing it more DIY, you still have to pay for more materials in some places, but a lot of it just isn't as big of a problem. So I've seen people DIY much larger printers than I would be able to just go out and like buy somewhere if for a reasonable amount of money. Did that do it? Maybe I guessed wrong at the M3x30 thing. I could be wrong. Maybe we check the CAD model. Okay. Alright, this is the CAD model. No, I don't need OneDrive. Go away. It's a little slow right now. That's cool. So we can turn off the shell. That looks like an M3 by 35. Let's measure it. $35. Okay, I'm just being a dunce with the nuts and the wrench apparently. Oh, DIY laser cutters. Yeah, that's something I've seen. I forget. I thought I had somebody with personal experience building a laser saw, but I don't remember enough of it to pass anything useful along. Derek asks where I buy my fasteners. I should buy them from McMaster, because when I buy them from McMaster, I get really good stuff. Some of the stuff I've been using recently, I just bought off of Amazon Prime because I wanted it fast. And it's been variable. Some of it's been fine. Some of it is probably fine, but I don't really trust. Those M8 by 100s that I got off of, I think, eBay were nice, but a little bit bent in some places. So, yeah, I've definitely got some eBay fasteners, and some of them are fine, but some of them are bent. I feel like I just need to jam this nut further in there. I don't know why this isn't threading, but I can see a little piece of plastic in the way. It's normally the kind of thing that I would just expect the bolt to just push through, but... Oh, that's cool. We got one recommendation that laser saw is alright, which is good. I mean, alright feels like a pretty great bar to shoot for in a project like that. And then apparently monster bolts on eBay is alright. That's cool. Let's check them out. I can see the end of the bolt in there. So maybe the bolt is too far in. Back this out. It's also possible I just cut some of these bolt clearances way too close. I mean, I guess you saw in the CAD that I was putting the nut on the very end of the screw instead of giving it a little room to thread. I'm going to put that one aside and go to this screw. So I'm just putting the nut on the end of that screw to the left just to position it, and then backing off that as much as I can while still holding it, and then turning the nut head on the right proper and hoping the two actually meet up in the middle. Oh, interesting. Michael Liebnow says that hypercube evolution design scales really well and is limited only by the stiffness of the frame. Is that a particular 3D printer topology? That was from the YouTube chat. He says the design calls for 3030 extruded aluminum, so it can be quite big before you have to start changing the design. This is ridiculous. Why is this not engaging? Can I just throw some M3x40s in? I just don't have a lot of M3x40s. Let's try this side. I feel like if I can get any of these screws to engage, then it'll start closing the whole thing. I mean, which I shouldn't do just yet because I need to actually put it around the motor, but I just want to make sure it fits. And then Nexus asks about the background noise. It's probably I mean, if you're hearing like fan noise, there's a fan here. If you're hearing like people doing stuff, then it's my friend. There's also the cat, who would really rather not be in the box. This is one of those situations where I would really just love for the nuts to just already be exactly where they're supposed to be and just like glued in. And like if I could just 3D print stuff that was already had like super strong threads embedded in it, that would be great. Aw, Guru account says hungry kitty needs tunas. The cats already have their dinner. I think he might want more food still because I've been kind of putting him on a diet. He might also just want to be outside the box. Now I think I lost the nut. Oh, these super deeply sunken nuts are annoying. The nut is sideways right now. I can tell, I just can't quite push it where it's supposed to be. Did that do it? I don't know, maybe. I can see the end of the screw rotating. I can see the nuts. I don't think the two are actually meeting each other. I'm just going to try to use something that is just larger that I can hopefully push down that nut hole and get the nut to stay flat. Like maybe this other wrench. Percussive noise, or percussive maintenance possibly. Wow, that is annoying. Well, I guess we could just go ahead and put this on the motor first, because like this is not going to get... I don't know how this is going to get less annoying. I think we're just going to have to put it together. Let's put this around the motor so that we can at least make useful progress. Okay, so the sensor wires have to go kind of under and to the left. These two halves go around the motor. The wires stay out of the way. So many dependencies here. I think this angle is causing a problem and I need to actually undo the other side further. That's the right place. That wasn't hard. I just had to find the right location for all the pieces. So, and we can go ahead and put screws in there. I think those are all M3 by 10s, but let's check the CAD. Eight. That looks like they could sure stand to be 10 though, doesn't it? Right? I think I was worried about that clearance, but it's not nearly that tight, so let's just use 10. Because geez, why did I think that was a good idea? Like, you're seeing that, right? It's like barely engaged. That must supposed to have been an M3 by 10. Oh, cat. I know. I tried letting him out a little bit earlier on stream, and it was alright. He was just getting into trouble way faster than I could deal with it at the moment. Maybe doing that on stream is not something I'm up for right at the moment. Hahaha, Electronoob says, imagine if all products had assembly info like that. Yeah. Yeah, exactly. Stuff like this is definitely low volume. Although you'll see some surprisingly weird stuff when you open up high volume products sometimes. Oh man, everything here is made of magnets. Okay, last time I did this particular step was super annoying because the nuts kept stripping and not being in the right place. But I think this time it's actually going to be easy because the nuts are all epoxied in. Oh wow. Cody Rosenman on the YouTube chat says that they found my channel yesterday and they think they managed to watch about half of the content since. Keep up the good work. Oh, that's great. Thank you. Glad that it's stuff that you enjoy. And then Christian Werrell is saying sand the mating surfaces. It should make it a bit easier. Yeah, that's a good point for those two. I'm looking at the surfaces right now and oh, that's so much sanding. I think, like, I hate sanding PLA. It's like very ineffective as far as I can tell. Unless you just do a bunch of it and then it starts getting melty. But yeah, I can see how that might help. I don't think it should be quite down to the like fraction of a millimeter, but that is a good suggestion. We can try that if we need something else. And then Gbone1 has a binary 1, 0. Is that a 2? Aw. Fred Schmidt has an alternate suggestion for a robot, a cloud flyer for our current box cat over there, which would be like a baby bouncer, and it would just carry him and let him bounce around. I bet he would appreciate that. He would still find some ways to get into trouble, but maybe we could at least have some human and or algorithmic ways of getting him out again. This is kind of a ball driver and prey situation. You just have to kind of like wiggle the screws in around the motor. is definitely one of the least glamorous parts of this design. This is mostly a result of me designing that top part that's in the lighter blue. I designed all that before doing any of this, and so I kind of left myself like a minimum viable connector and figured, oh, I'll do something with this. And like, yeah, I guess I will. I'll make it. I do that for myself. I give myself kind of an annoyingly hard problem to solve sometimes when I could have made it easier. This is definitely better with M3x10s. I think I might have tried to use shorter screws last time, and this is so much nicer. I think I thought the longer screws would be too hard to put in around the motor, but it's not that bad. Spider cat. Oh no. That cat doesn't look like he's having fun, although that also looks like a very... Oh, actually, I don't know. Yeah, he is kind of moving his paws like on the ceiling. That's interesting. I wonder what Tuco would think about that. I should remember not to tighten these down too much until I have these, because you can already see it's kind of trying to pull these apart. And so I want to tighten these all down and then torque those down as much as I feel like. Why do some of the GIFs embed and not others? That's interesting. Electro Noob says, in before home pro QRP rigs. Yeah, this is... We might have a risk of some ham radio nerding out at some point. Oh, G-Bone says 10 millimeters. The 1-0. Yeah, I have to say, these M3x10s are nice. Although if we were talking about ham radio, maybe there's the 10 millimeter band, which is a little small for ham. Aw. And more kind words on the YouTube chat from I Have Two Faces, who says, I found your channel on Reddit yesterday. Your breadth of knowledge is amazing. It's awesome to me how expertly you're approaching a cat cam. Aw, thanks. You know, I'm the sort of stubborn engineer type who just likes doing things as, I don't know. I'm not gonna like BS about like always wanting to do something as well as I humanly can, because like everyone runs out of steam and gets frustrated and stuff, but I really enjoy when you do get to try to kind of like put your best enthusiasm into a project. And so it's been nice trying to find as many of those moments with this as possible. I think I've just got to push the other end of the nut in with something. I just don't have a lot of tools that are exactly the right size for this. Is this the right size? That is a little too big. What about this? Does this help at all? Oh. Apparently I can push through the middle of the nut. The nut, maybe the nut just isn't sitting as far back as it should. Someone suggested percussive maintenance. I'm starting to think you're about right. Can I do this without having it on the other side? It feels like it's already in all the way. I don't know, man. Let's try that again. Derek Bonner says, what about embedding the nut during printing? That's a good question. Would that have worked? I mean, there's a couple other ways I could have done this. I could have probably put a slot on the top and just slid the nut in for this one. I guess the reason I did it this way mostly came from making it symmetric, because I had several nuts and like the others wouldn't have been as easily accessible. There are places where I slide in the nut from one side, which works pretty well. Embedding it during printing, I don't know. So far I haven't seen a case for that being actually easier. It mostly just seems like kind of a hassle, because like printing a large part like this is already kind of a complicated process, and embedding hardware while printing it just seems super annoying. Oh, what is my stash of M3x40 bolts like? This might work. Maybe we just graduate up to M3x40. Are the bolt heads too big? No? Cool. That's a little annoying, but I guess I did missize several of the bolts in this design, and it's not the end of the world. To make it easier to remove this, I'm going to try to jam this little spudger in here, which I'm hoping will act kind of like a nut, and will let me thread the screw out instead of it just slipping. Oh, that's a good suggestion from Christian again in YouTube chat, who says use wood gluing clamps to put the parts together before you fumble with the screws. Yeah, I don't have like a good full set of those like kind of big ol' ratchety clamps that a lot of carpenter types use. I have a lot of these small clamps, but they're not the kind of thing that you can use to get like big surfaces like this super lined up. Anyway, let's try a smaller screw, or sorry, a longer screw, but it also happens to take a smaller wrench for some reason. How's our nut doing? The nut is way over there. It still needs a bit of a help. A little bit of help. Huh. I think I'm just bad at nuts. And I keep getting it slightly twisted in the slot. I mean, I've definitely got plenty of bolts sticking out now, but it looks like maybe that wasn't the original problem. What I really want is a little hexagonal piece that's about the same diameter as the nut, maybe a little bit less, that I can stick in there as like a press. Obviously I could 3D print that. It would be a little bit of an annoying shape to print because it's so little and thin. Like it would be... Well, actually I could just truncate it. Like I could do a truncated hexagon and then print it flat on the bed. That might be a useful tool to have. One of those WTF moments where it's like, why are these threads not engaging? I don't see a reason why they're not engaging. Can I use a Q-tip to push this nut in? This is why my threads are not engaging, because I don't use the right tool for the right job. even is the right tool for this job. Yeah, maybe I do need to make a little tool for this. How did I do this before? Did I just get lucky? Did I use a little flat-bladed screwdriver? Yeah, this is mysterious. And it's like, I mean, I think that the chamfers on the edge of the nut are such that if I pressed it flat, it would self-align. But maybe all of the tools that I'm using are also pressing it in the wrong direction and causing that not to work. It's also possible that it would just be easier if this was already clamped. I don't have a great clamp for that. I could use a C-clamp. I'm going to skip clamping because I'm a little worried about just messing up the print. But that might be a thing to try. Opposite end of the Q. Actually, I already tried this end of the Q-tip. This one's actually thin enough it goes through the nut, so then I was pressing against the edge of the nut, but I think the uneven pressure was not helping me. And then the fuzzy end, I just don't think that was really working, and it was getting a little stuck. Alright, C-clamp. I'll get a C-clamp. Looks like we've got a VM bug. Oh, hi Hedberg. Oh no, nasty bands of low fill. I've had that problem. I mean, there are a bunch of reasons why you could have that problem. One of the ones that I had in the past that was kind of unexpected was actually due to the cable between the stepper motor and the stepper driver for the extruder was starting to wear out. And so it was dropping steps just during parts of the print based on where the cables were pointed. Oh, I should really have like some larger C-clamps. I don't have a lot of C-clamps. Can I get it back here instead? Is that going to be good enough? I don't know if that's working. Whoa. We have a £5 super chat from Electronoob over on YouTube. This is one of the YouTube flavored chat donation features. Thanks so much. It is for the stream being nuts and bolts. Oh, thank you so much. Oh, well, the nuts and bolts, like, I feel a little incompetent at this right now, but I mean, I could just use this as an excuse to design a little tiny 3D printed nut pressing tool. I'm just surprised I don't already have something on my desk that fits these descriptions, because it's not that specific. Is this spudger thin enough? Oh, no. That is a tiny wrench. No, none of those things seem useful for this. Maybe 2 of these wooden sticks. Oh, what is this thing? Oh, is this useful? It's a metal stick with a pointy end on the other end. So that maneuver would have been a little dangerous. How does this even work? Huh. Oh, did I lose the nut? Did that just happen, or? Okay, maybe I lost the nut. Let's try a new nut. I really liked the method where I put it on the end of a long screw. I don't know why that hasn't been working so well. Oh wow, 12,000 subscriptions. That's really nice. Yeah. I'm just really happy that so many people are finding the channel. Oh yeah, Jarrett Rayner says they've had some pretty fantastic experiences lately with those heat set knurled nuts. We will be using those actually potentially even on this stream in just a little bit. I just don't use those for the really heavy load bearing stuff, because in my experience it doesn't take that much torque to actually strip them out. But if you have a secret for actually putting them in more effectively, maybe there's something I'm doing wrong. Okay, can we go to this one again? Oh, is this one finally engaging? Yes. And is that still... That's still an M3x35. Okay. I'm going to go back to this as designed, I think, and take out the M3x40. Because I think the problem is not related to length right now. Is that working? I think so. This side is sharper. Let's put the less sharp side against my finger. Ha ha ha! Deflame says, so how late will it be when I decide to just epoxy the rest together instead of dealing with the pesky bolts? The bolts are pretty important for this design. I don't think I can avoid the bolts. I'm happy to use epoxy to help the bolts out, but... I mean, less important for this particular bolt. This really just kind of keeps the bottom frame in one piece. I don't know. The 2 bolts on the front are less important and are partly just there to hold the emergency stop switch in place. But the one in the back is actually pretty important. Oh my god, was this not an M3x... This bolt was in the wrong bin. This is an M3x30. Dun dun dun. Zoom into the squirrel. Oh, this was in the wrong bin. This is an M3 by 30. Okay. Well, that explains why I feel so dumb. And why we should go back to the 35. I mean, I guess I can try my luck. I mean, I know there's some actual M3 by 40s in there. I just grabbed one that was clearly not an M3 by 40. You know, I didn't expect this stream to be entirely about nuts, but I just keep dropping M3 nuts everywhere. I could see the end of the nut in there, or into the bolt too, so that's weird. I wouldn't have expected to even be able to see it if it was that much too short, but I guess the lighting was just right. Also, this thing is creeping me out. This pokey thing that I keep wanting to stick my eye in. Put that down. Let's use an actual M3 by 40 as our pilot bolt. Oh wait, what? I grabbed another. I must have mixed in some shorter ones at some point and just thought like, oh, it'll be obvious. Some of these are obviously not M3 by 40. I should have changed the label. But now, obviously, I need to change the label because there are a bunch of M3 by 30s in there. Oh, is this just going to work? I mean, it's a little bit... there's a little bit of a gap there, which I might need to tweak this. Just almost feel it biting in. Oh, the nut's a little crooked. How is the nut crooked? Huh. I mean, I guess, would it be cheating if I went to an M3 by 40? I was already planning on going there. But now it's like, now I'm just doing stupid things with this nut again. I can see that so clearly. It should just start threading, right? I can hear it clicking now when I turn it. That clicking is the nut wobbling around. The nut is sitting there and it's moving around. It's just failing to thread. It looks like it's binding on the side of the hole because of the stresses involved in having already tightened the little M3 by 10 screws around the motor. So maybe that was the mistake. Maybe I need to go back and just loosen those and then tighten this. I should also wrap it up soon here because it's getting a little late. Not that I don't like working late, but... also be nice to hang out with my friend since he's home. He might already be trying to go to bed, actually, which is another reason to stop. Okay, so these are all looser. nut is kind of hanging out nearby, but... Okay, let's come back to this one and try the one on the other side. This one should be roughly the same. Oh, it's so close. All right. I should just switch to the longer screws. I'm taking this one out. Oh, Andrew was saying use a bolt with another nut on the end to press the problem nut into place. That's what I've been doing, and I've certainly had a lot of luck with that strategy in the past when it's been an issue of just pressing it into place, but yeah, I think maybe something else is going on here. I think it might have just been really tight tolerances to begin with, and then there's also some flexing going on here where it doesn't quite want to line up. I don't have very many M3x40s. It is tightening and the nut is sideways. That's not what I want. Yeah, I think then the bolt is getting stuck between the nut and the wall of the hole. Oh, nice. J Nugget on YouTube chat says they found my channel a bit ago and they're impressed and spammed all their friends with links at 1 in the morning. Aw. I hope your friends appreciate that. Yeah, you can see that like, that's where it wants to be. And now I'm trying to take out the nut so I can inspect it. Oh, M3 socket wrench. Yeah, I wish I had room. The hole is fit. Oh. This nut is all chowdered up. That one, I think I missed the trash can with it too, so I'll just have to step on it later. that's nice. Yeah. I thought I tested the nut, so I'm assuming I just did that myself. I'm doing the thing again where I press the nut in that way. Take another M3x40. This is kind of working, I'm just failing to transfer the nut from one bolt to the other. It looks like it just looks like things are slightly crooked. It's like, I could draw this on a Post-it, but I'm feeling even too tired for that. It's like then the bolt is kind of coming through the, there's a cutout that's just barely large enough to fit the nut. So the nut slides down there. There's the bolt that's supposed to run right through the middle of there. I think it's just tilted so that it's kind of running up into the wall, and then so the nut can't get over that onto the edge of the bolt. I think that's what we're running up against. So I think I actually need to shift the alignment of the two pieces relative to each other as I'm trying to tighten this. I think that's working, the nut is just too far away. Just need to push the whole thing back. Oh, did I just cross-thread it? Oh, I think it's on. I think I understand that problem a bit better now. Ryan votes 6 Red Bulls so we get to see it finished. I think I'd rather do the thing where I have sleep and then try this again more tomorrow. I at least want to get this together though. Oh, I think Zach's already asleep. I think I can hear him snoring. I guess I'm not going to get to hang out with him. So I guess I'm just here with you. It's fine. He was probably tired anyway. He was helping out a friend of his recently, or he was like all day over at a friend's place who just lost their job. Oh, this is so close. I'm like almost extracting the nut again. Sleep is for those who need power management. Yeah, I know, right? I get that. Oh, is that working? No, the nut isn't even coming off there. Okay. There's probably no like exciting milestone that I can make it to tonight with the remaining energy, and this is frustrating. So I think I'm gonna wrap up this stream. But there'll be more of this soon. Just putting stuff together, also doing other things. I'll try to avoid just having a bunch of monotonous streams that are all the same thing and try to mix it up more. But oh, Hedgeberg is asking if I saw the clock loop foam. That name is not ringing a bell, but I'll have to check it out. Internal power management tools. That sounds totally like a thing that I would expect to exist, but I am not familiar with that one. Mikey asks if the soothing tones of Zach sleeping is going to the final cut. Yeah, I'm probably not going to use, like, a lot of the time I know I'm not going to be using any of the audio, and so I'm not as worried about, like, the fan noise and stuff, but it's more about just, like, trying to have an alright experience for the streams. But alright, thanks so much for stopping by. Special thanks to all the regulars, special thanks to all the new faces, and extra special thanks to everyone who donates on Patreon, because you're helping me pay the rent, and it's awesome. So, yeah, I think I'm going to try to wind down here and wind up with the same thing again tomorrow. Oh, clock screw. Nice. I'll have to check that one out. And, yeah, good night. More hacks, more cats later. Until then, some sleeping. It's so nice to see everyone who stopped by. Happy hacking. Also beer for those who joined on that note.